Thank you for being here. We have a light audience. The focus of this evening's presentation is the transition to the next generation science standards, which we have begun to undertake here in the district as the state of New Jersey transitions to new science standards over the next couple of years. Karen Chase would have been assisting in this presentation with Kristen Crawford, who is our supervisor of science K-12, but Ms. Chase had to leave a little while ago, not feeling well. So I'm going to turn it over to Ms. Crawford, and she is going to talk to us about Next Gen, and she may also comment on her time in the district so far, as she is one of our new supervisors and has been working very hard to get to know everyone and acclimate herself to the district and our schools. So Kristen, it's all yours.
Great. Well, thank you for having me. I'm excited to tell you about these new standards, especially since I'm just coming back from a national convention in Philadelphia, where it was all science, all the standards, and so very exciting. And so I just kind of want to walk you a little bit through the standards and some of the work that's been done on the standards thus far in the district and how things will be changing slightly. So first, one of the questions that we get is who wrote the next generation science standards? So these standards were written by a group of participants from 26 lead states in the development stage. They had representation from every level of education. And the standards are based on a book entitled A Framework for K-12 Science Education from the National Research Council, excuse me. I do have a link to it at the end. You can download a free PDF. It's great reading if you have several hours.
I'm sorry.
Sure.
Do you want us to ask questions now?
If you would like to, please feel free.
So out of curiosity, do you know if was New Jersey part of the 26?
New Jersey was a part of the 26, yes. Mike Hines, who is the Director of Science for the state of New Jersey, was a participant in the writing of the standards.
How many participants? Is it one per state, 5 per state?
It was a consortium of different levels. So it was, elementary representatives, middle school, high school, college. I don't know specifically how many from each state were there.
But I'm really looking for the number of participants to put together one document, like 100 people or...
That's a good question. I'm actually not sure, but I can find out for you.
No worries. Okay, thank you.
No problem.
And just for,
Sure.
sorry, just
No.
for my own, could you explain to me how this relates to the Common Core?
I'm getting there.
Oh, okay, perfect.
I promise I'll get there.
Okay.
So partners that wrote the standards include the National Research Council, the National Science Teachers Association, the American Association for Advancement of Science and Achievement, and their motto is it's written by states, for states. Okay. And so I'm sure you'll have some more questions as we go along. This was the development process in the writing of the standards. So the writers were identified in the summer of 2011. There were drafts written by states. The drafts were released on the Next Generation Science Standards website. Once that happened, there were many reviews. Anybody could actually go into and on the website to be able to respond to the draft. And after the draft was kind of responded to, the writing team kind of came back together, and the final release of the standards was in April of 2013. Now that's nationally, and I'll give you a timeline for the state of New Jersey and what happened there as well. So as you can see, the process was very long and lengthy. It wasn't just written over a year. And as the draft was released, a lot of different districts were trying things out based on the draft.
So were they piloting specific
lessons, and they were also looking at sort of a progression. One of the things that the standards does well is they look at the progression of a particular standard from kindergarten all the way to high school level. And they do, in my opinion, a really great job at looking at the developmental age and what's really appropriate for each age group. So far, these are the states that have adopted the standards. So you look at that and go, wait a minute, why is it so blank? So what's happening is Because of the rollout of the Common Core and so many states adopt a Common Core, I think a lot of people are a little bit slower in reviewing these standards before they adopt. But just knew this week that after I made this, and they don't have a new map up, but Connecticut and Michigan have just signed on to implement the science standards. And when they count the states as implementing the science standards, it's full adoption, but many states are taking the science standards, tweaking them a little bit, and then adopting them. And so they don't consider them full adoption states. Like you can see that one of the states has adopted similar ones. So the work at the New Jersey level, I was actually a part of the focus group with the state of New Jersey, again, a consortium of elementary, middle, high school, higher education people who came together at Middlesex County College, and we read the framework for science, as I mentioned to you before, and we went through every single step and discussed all of the standards in various groups. We met probably 4 or 5 times throughout a school year, and then from there, the focus group was narrowed down to less people. And I was a part of that, so I was a part of the committee to write a letter to then Commissioner Cerf in 2013 that we wanted to adopt the science standards, because they're very well written. The process of the way students or children will learn science is more like the way scientists work. And I'm going to get into that a little bit more. So the process in the state of New Jersey was also another slow process that went on for a while before we decided to adopt, before the whole decision was decided to adopt them. So the standards are written like no other standards I've ever seen. So if you're familiar with the Common Core standards, this is very different. These standards were written based on what we call 3-dimensional learning. And so I'm going to take you through each of these dimensions, and at the end I'll tie it all together so it makes a little bit of sense. So we have our practices, which are our science engineering practices. We have our core ideas, and we have our cross-cutting concepts. So you'll see this symbol kind of throughout. This is sort of our logo for the next generation science standards, and all of these come together for 3-dimensional learning to happen for students as we go along. So I'm going to walk you through each of these. So I like to think of the science and engineering practices as what do scientists do? So what do they do on a daily basis? So when you think about scientists, we always have this image of Einstein in a white coat, right? But what they do, they're very collaborative in what they do. They investigate, they build models, they come up and have to design their experiments. There's not necessarily this linear way of the way science happens in the real science world. I recommend reading the book The Martian or seeing the movie The Martian. It's a really great book. And I was actually on a webinar with an engineer from NASA who was instrumental, and she's worked on every single Mars rover. And I had to ask her about the book, and she said, those are my people. This is the way scientists work. They work in a room together, and each one has an expertise, and each one brings something to the table. And so this is the way we want to get students to think about science as coming to the table and coming up with these ideas and doing these problem-solving things, which is happening in Chatham, I have you know, which is a great thing. We're kind of getting ahead of the game. So these are the 8 science and engineering practices. If you're familiar with the Common Core standards, like for math, there are 8 math practices as well, so that's a magic number, I suppose. So this is what scientists do. They ask questions, develop models. We add a lot of math. You know, I always say math and science are very closely related. They construct and design explanations. They engage in argument from evidence. That word argument can be a little scary when you're thinking about a 3rd grader, but when we're talking about argument, we're saying, this is kind of the way I feel. What do you think? Or this is my evidence. We want students to be able to come up with the concept, be able to argue their point, show their evidence, and then someone say, but what about this? This is the way the scientists work, and we really want them. The standards really brings that home. So what does it look like? This is a natural progression of making a claim and using your evidence, as I just spoke about. So you can see at kindergarten through 2nd grade, so making a claim, it could be as simple as, I saw the grasshopper and the grasshopper is green. Well, what is your evidence? Well, here's a picture of it, or here's my drawing of it. So it can be very simple at the K-2 age. And when you go up to high school, they're constructing a counter argument. So they might have someone who states a claim and they're saying, yeah, but I think this way. This is the way scientists, it's not always we go through our experiment, come up with our conclusion, and we're done being a scientist. There's always more questions, and there's always someone who's going to counter your argument and come up with other evidence in scientific papers. So I have a video that I'd like us to see a little bit in action. This is at a 4th grade level.
Phew.
This is not happening in Chatham, but
Yeah. You're gonna eat those words.
Well, I didn't do so well in the 7th grade park.
I think about just that first part of my investigation, and I think about the question I need to answer. What do you think caused Waterlow's drive in this case? Was that aluminum or that copper cube right there? I say, you want to talk to the board about the conclusion you came up with? Let's make sure everyone's looking at the tape to show that we're listening to him. Well, my view, we found out that we thought because it was because of the volume, because we found that the volume and the water level were the same, but the weight was different. And I thought that if the weight was there was more weight in the copper cube than the aluminum cube, then I think it just should depend on the volume because the weight, if it was more, if the copper cube is more, then it would have more volume if it really depended on the weight. Does anyone respond to that? Who wants to respond? They listen to Mateus's explanation. Kind of respond with their own ideas or can add another idea to it. Like go ahead. Dr. Mateus about how you feel about what he said. I agree with what you said because this, for example, like if you had a big if we get a big cup of water and you put an eraser in there, but with the eraser over there, if you put something like that in a big cup of water, the water level will rise a lot. And if you put in a copper cube, it's not gonna rise that much, even though that copper cube was way more than an eraser. Can someone explain or repeat first what Flavor thought would happen if I put an object this big in water? Javon, what do you think would happen if I put an object this big into a cup of water? So that if you have like a big bar, where a big bar of like water, you put the eraser in, then it would probably like rise a lot. Why? What would make that level rise a lot? What is it about this object that would make the water level rise a lot more than, say, the copper cube or the aluminum cube? Because that has a different volume than the copper cube. Elise, you want to share some of your thoughts? Well, I kind of disagree because, like, with Flavor because... Drop to him and tell him why you disagree with him. I disagree with it because, like, the eraser comes up with the water. I actually want to add something. I have a question for you, Flavor. What if the object has a buoyancy, like it's able to float? I think that's a big question to hold in the right place. And that it would be a different story because if it had buoyancy, then it wouldn't really be taking up much space. But I don't know if, so some things that have buoyancy, it would do something like I was talking about.
as you can see from that video, there was a lot of conversation going back and forth between these students, and it's, I agree with you, I disagree with you, this is the reason why, this is my evidence that's happening. The teacher becomes the facilitator in there, and having students speak to one another instead of just putting this blanket statement out. And I like this example because this is where we are going to get to, and this is where what is happening now in some classes. And we talk to students about, and teachers about getting students to state a claim, showing their evidence and their reasoning behind it. So our cross-cutting concepts, so that was our science and engineering practices, and that was just a couple. That was a little snapshot. So our cross-cutting concepts are how scientists think. It's kind of how they put the puzzle together of science. And so we think about, energy. There's energy in so many different areas of science. And so how does energy go across food chains? How does energy come from the earth? Those are different things that we want students to make these connections. It's really about making connections in different areas. So these are our cross-cutting concepts that we do cover in the standards, talking about cause and effect, system, structure, scale, energy and matter, stability, and change in patterns. So all of these things happen throughout our science curricula. And we make connections through life, earth, physical. And that's the whole point of our cross-cutting concepts. So I do have another video that's going to be a little shorter. This is at a high school level to sort of see this cross-cutting concepts in action. It's not going full screen.
Welcome everyone. I'm so excited to see all of your designs today and to hear your amazing thinking. We are going to start the video explanation portion of our Rube Goldberg. You want to create a video explanation that explains your device. My name is Tricia Shelton. I am a science teacher in Boone County, Kentucky. I have been teaching high school science for 20 years. I teach anatomy and physiology, integrated science, and biology. Included in your explanation should be one run of your entire machine. All right, good luck.
We've been learning about transfers of energy. At first we started learning about food chains and ecosystems and how energy transfers through there. Then threw a curveball into it, and that was all life science. She threw a curveball into it and added physical science into it.
We have been focused on a study of the conservation and flow of matter and energy within a life science system. The students expressed an interest in incorporating a Rube Goldberg a couple of months ago, actually. So this became our opportunity when we were studying the life science system for us to transfer that to a physical science system. And the umbrella, so to speak, for our class has been the cross-cutting concept of energy.
So today we built a Rube Goldberg machine to understand energy transfers and how that works.
We were moving back and forth between a physical and a life science system throughout the day while we were deepening our understanding of the conservation of energy and applying a new situation of discussing efficiency. Students really need to have an understanding of how to communicate evidence-based thinking. So that is something that from day one that we have tried to develop that seed.
As objects interact with each other, it really just transfers the energy and it causes a series of events to unfold.
When it hits the car, that's a transfer of energy. It goes from the dominance to the car. The kinetic energy transfers. That was awesome.
So I don't want to watch the whole entire thing, but you understand the point. And I was curious about why that dog was in that classroom as well. And so, but you know, what I love about this is they were talking about life science, and they're transferring that whole idea of energy from life science to physical science. So it's across these disciplines. And when you're talking about energy, period, when you get to the high school age, they should be able to make these connections between all of these curricular areas. And that's the whole purpose of a cross-cutting concept. No more videos. That was our last. So we talked about our practices. We talked about our cross-cutting concepts. So now these are our disciplinary core ideas. So when we think about our practices, it's what scientists do. And our cross-cutting concepts, it's how they make connections. And this is what do scientists know? This is like the meat and potatoes. So this is the content that we want students to be able to understand. So these are the big ideas that scientists and engineers will build their foundational knowledge on. Okay, so our disciplinary core ideas go from life, physical, and earth and space science. So the earth and space science is actually more prominent now at the high school level. That is a big change from the New Jersey state standards. And the other big one is our engineering and technology. So our engineering and technology is really, we want students to be the engineers of experiments. We want them to it's using that engineering design process, but it's them coming up with how they are going to plan their experiment. How are they going to answer the question that we want them to figure out? And so that's where the engineering and technology come in. Of course, in design and technology, Students do use the engineering process. There are some next generation science standards that are happening in there, as well as in the science classroom. So they're kind of getting it a little double, which is great. So this is a good way to think about this three-dimensional learning. So we're talking about, it's like making a really good meal, okay? So it's the cooking techniques or the practices. How am I going to prepare my dinner, okay? Am I going to bake it? Am I going to fry it? Am I going to grill it? Those are our practices. The core ideas are your main ingredients, and then that added spice is those connections on the top. And this is the way that three-dimensional learning will work and how it happens. So you can think of any analogy you want, but I think that sometimes this is a good analogy of how they work together. So if you have the techniques of what you can do without the ingredients, your meal's not going to really work. Then you can have your meal, you can have the practices, you can have the contents, but it won't taste good unless you get that spice on the top, okay? So this is a really good analogy of the way we get our cross-cutting concepts. So here's to your question, how does it connect to the Common Core standards? When they were creating the next generation science standards, they did use the Common Core not as a foundation, but to refer to, simply because a lot of the practices kind of coincide with one another. And this is a great diagram, a Venn diagram here in the center to see how they all sort of connect. We read, write, and speak grounded in evidence. This happens in reading and language arts. In a reading and language arts classroom, a teacher is asking about a topic or something that happens in a story. Well, what is your evidence that it happened? Let's go back into the text, okay? Also in math, we talk about evidence in math. Well, how did you get to that point? We have a lot of math talk that's happening. So this is where all of these areas are going to work very nicely together. They also have at the end of the Next Generation Science Standards document, in the standards, how are these standards connected to reading, language arts, and also math? So it's kind of saying, if you are going to tackle this, this is the math foundational things that students should know prior to getting to the standard, or these are the ways that you will incorporate reading and language arts into this standard. So the document is really well written in that fashion.
Sorry, can you just ask a question? I have
Sure.
other questions, but this one is right in front of us.
Okay, go.
I don't want to jump
Sure.
off of it. Now,
Yep.
does this Venn diagram apply to all the levels, K to 12? Is it just high-level conceptual? Or does it build over time and you do a lot more cross-learning?
It's really K to 12 because these are sort of the foundational ideas that we want them to do. So those math practices that we have in the Common Core math, the 8 practices go throughout all K-12, just like the science practices will go through K-12.
Right,
So,
well, like for example, E1, it's difficult for a first grader to demonstrate independent reading complex texts because they're just not there yet.
well, but they,
Their text complexity is complex to their.
it's complex on their level, is what we're talking about. So independent reading, it's something that they're working on.
Okay.
You know, and if we're looking at, you know, independent reading and nonfiction reading that's happening at the science level, you know, those are simple kind of words. We're talking about vocabulary, ways that they can identify things. So that does happen
Okay.
at their own level.
Sure.
So, you know, the standards do a really nice job at showing a progression that can happen in that way. Did you want to ask more questions, or you want to wait?
No, I don't want to derail you. I have
Okay.
them written down and I'll circle back at the end. It's just that this visual is right in front
Yep.
of us. And
This is, again, I have, my PowerPoint is already on the website, as well as I have resources at the end as well. So you'll have access to all of that. And you know, it's fun, in that video that you probably didn't notice this, but in the video of the teacher that we saw at the high school level, she has this image on her bulletin board in the background, talking about how it all fits in together. So this is another way to look at our practices in math, science, and English language arts. So analyzing and interpreting data, modeling with mathematics, we model with science. We are planning and carrying out investigations, attending to precision. You have to do that in math, you kind of have to do that in science as well. Engaging in argument of evidence. They're looking for evidence in math. They're looking at the value of evidence in language arts. So this is a way that you can see how, another visual, good way to see how these connections are happening. So this is the plan in New Jersey for the implementation. So I talked a little bit about how we adopted, how the standards review went in the state. And so July of 2014 is when New Jersey adopted the standards officially. And then when they adopted the standards officially, they gave us till 2016, the fall of 2016, to implement the standards for 6 through 12. Okay? So the announcement happened in July. They said, we'll give you some time. And by the spring of 2017, they will update the New Jersey biology competency test. The way they are going to update it is they're going to make it a little bit more application-based and less focused on just content knowledge. So some scenarios, more open-ended questions, that kind of stuff. And then by September of 2017 is when we will implement NGSS at K-5. This is official by the state, and I'm going to compare this to what our rollout has been in Chatham. And then by spring of 2017, the New Jersey Ask for Science at grades 4 and 8 will be updated as well.
That should be Park, right? Not in,
It's not Park because it's not Common Core.
Oh.
So they'll still keep it at NJ Ask because it's going to be a state level course. Whether it's or a state level test rather, whether it's going to be computer based or not, we're not really sure yet. They still have the actual bids out at the state level to get, a testing company to develop it. Currently with NJ Ask 4 and 8, the students really only need to get about 33% of their tests correct in order to be proficient. So the stakes are not that high. When it changes to the applications, it might be a little bit higher in that regard. But we always do very well on the test, and students really do well in the science, so we're not really concerned about that.
Can I just ask you one? So
Of course.
At this point, is every state designing their own testing mechanism?
That's a really good question. It depends on the state. Not many states will hold value to science and testing in science. Not every state has science as a tested subject. New Jersey does, Massachusetts does, some parts of California, they do, but not every state does. I don't have a list of all the states, but I can get that to you if you're interested.
Okay, thank you.
Good question. So instructionally, what are the shifts that are going to happen instructionally in the classroom? So we want them to look at things in the real world, the wonderings in the real world. And, I have 2 children myself, and I try to look at this when they ask a question, and I try to facilitate some good conversation and have them think a little bit about what's happening in the real world. And, children naturally have these questions that kind of go along, and when they have these questions, that's what we want them to try to figure out. Well, if this happens and this happens, this is how we want them to make those connections. All of these practices, this 3-dimensional learning, is going to be taught integrated across the core concepts and all throughout the year. So it's not all done in isolation. It's not like, it's not a checklist. We want it to happen as often as possible. And the building, again, I've talked about that a little bit. It's a focus on a deeper understanding of the applications, as I said. So it's applying their knowledge of what they know, the integrating of the engineering, and then the Common Core standards. So, I think with having some background with the Common Core standards, it will make some of the things that are happening in the classroom, like these concepts, a little bit easier to kind of roll out because they're used to doing it, and now that we're just doing it in all these other topics or all these other areas that we're teaching. So the high school plan here at the School District of the Chatham, so some units have already been written prior to me coming on board for the aligned to the next generation science standards. Currently, I have some staff that have attended the conference that I attended in Philadelphia, and they've done some presentations about talking in evidence and showing evidence and argument. So they're attending conferences. We've done a lot of curriculum articulation meetings so far on the staff development days that we've had, going through the next generation science standards. Every staff member in the science department has as their professional development plan to be well versed in the next generation science standards by the spring. So that was something that was a goal of mine. That was a goal that I've had for every single one of the staff members. The state of New Jersey is having also workshops that are happening throughout the state. to in specific content areas. And so our staff are attending a lot of those, and the best part is they're free, so that's even better. And we are also working on trying to get some more professional development in this year with some staff members from people from Raritan Valley Community College and Princeton University. They work in a consortium to work with districts to do gap analysis of the curriculum, and also we're working on that vertical articulation so we know what students are going to be coming in with. So all of our curriculum will be written by the spring.
Including what was here before you arrived?
Yes,
All
so
be rewritten?
all of it from 6 through 12
Will be rewritten
will be rewritten
Okay.
and be aligned to the next generation science standards.
by September of 16 or
Yep.
fall-ish?
6 through 12
6 through 12,
Yep.
and then the following years?
is going to be K-5. However, well, I'm getting to the K-5s
Okay,
next.
okay, forget it, sorry.
That's okay. That's all right.
But you had just mentioned that some of it had already been written before you arrived.
Right. So that's going to stay.
Okay.
We're going to review it just to make sure that if we need to make any changes or to tweak it. With a curriculum document, I always believe, too, you have to live through it for a year.
Okay.
And you have to be able to make some changes because, sometimes things look good in paper, but when you live through it instructionally and pace it out and look at your resources, sometimes you need to make a couple of changes, and it could be flip-flopping a unit here or there, that kind of thing.
Okay, so they're fluid.
Fluid doc, I see them as a fluid document. And again, the standards really are, it's the minimum of what we're teaching. We need to reach these goals. We need students to reach these performance expectations. I always say to teachers, is it the worst thing in the world if we teach more? Oh my goodness, that's great. If we have time to be able to teach students more, then let's do that. So the middle school plan is probably the plan that's going to be changing the most. And so currently, our sequence of the way we teach is 6th is earth science, 7th is life science, and 8th is physical science. So we really departmentalize those. In my conversations with science supervisors throughout the state of New Jersey, because I'm a member of NJ Stella, which is all the science supervisors, about 90% of districts throughout the state are doing an integrated curriculum. So when I say an integrated curriculum, by 6th grade, we're going to cover some topics in life, earth, and physical, and the same in 7th grade and the same in 8th grade. There are 2 sets of model curricula that are put out by the state. The second is being released very shortly, but I got a little sneak preview, which is exciting. So those are all integrated curricula. So really it's about the story and the progression of where we want students to be. So I always say, you can start with little tiny molecules and things that are really small and go macro in one grade level. And as we see these cross-cutting concepts and the connection between all the sciences connect, and I can write a story that'll be different from your story, that'll be different from your story. We want to make sure that it's developmentally appropriate for each grade level to be able to tackle. All of our teachers are certified to be able to teach all of these different areas of science, so we don't really need to worry about that. So this is probably the biggest change of all. So one of the things is the state workshops that I'd mentioned to you all. I have our middle school teachers attending those workshops, but I have them attending in the content areas that they don't currently teach, because I want them to sort of see the other aspects of them.
Can I ask a question?
Of course.
And I know obviously a middle school teacher who's been following what we've been doing here kind of develops, depending on how long they've been here, a science teacher develops their comfort level, their
Right.
area of expertise. Are you offering, or is the district offering these teachers opportunities now to go observe other science classes in their buildings? So if I am an earth science teacher, and maybe I'm not super comfortable in another area of science, are these teachers kind of getting an opportunity to see, although they are not currently aligned with the standards, the practices, and the principles?
Well, so for them, in order for them to have their certification to teach middle school science, they have to have content knowledge in all areas of science. So they do have content area in all areas of science. Whether they practice it, currently is a different story. So one of the things that they need to do is we really need to get them to understand the standards first before we get them into all of those other classrooms. And it's only simply because they need to really understand the depth of what they're teaching. Because I think if they don't understand to the depth or the knowledge that they're teaching, to walk in it could be very overwhelming to say, I don't really know this. But for them to look at a standard and say, this is what I need to teach them, then that is, one step. The other piece is I feel that, watching a colleague teach is definitely valuable. But I also think that having, going into other workshops to have different members of the state to say, here's our content, this is what we're looking at, is valuable. But I would definitely consider that as a good suggestion and see if teachers would be, amenable to going into and looking at the way the things happen. I have to say that the middle school teachers on one of our staff articulation days, they sat in a room, they kind of laid out everything that they teach, and they all worked well together to talk about the progression and of what they would like to see. And I'll be honest, it was very heavy. So 6th grade was very heavy on the earth science. 7th grade was very heavy life science, and 8th grade was very heavy on the physical science because that's what they're used to. We have to integrate it a little bit more. And it will be a learning curve, absolutely 100%. But they know the students. I think the other obstacle is the level of the students is the same. So meaning that middle school students are middle school students. These are standards are all for middle school. So I think that knowing and understanding how kids learn, that's an obstacle that they don't have to really worry about. But we'll get there.
Sorry, Michelle.
No, we'll get there. We will get there. And
I without a doubt.
Yep, and we've looked at a lot of resources to, I've introduced resources to them already to get them comfortable and looking through things with what they want to teach.
We have great teachers at the middle school.
Right.
I'm all about the support for teachers.
Right, absolutely.
And toward that end, I have a question. What percentage, roughly, and I know you can't give me an exact, but just a 30,000-foot level, based on the new standards, and let's just stay with middle school as an example, what percentage of their lesson plans may have to be modified? Is it 100% have to be modified? Can they reuse 50%? Again,
That's a good question. I mean, I would say a lot of them need to be modified because it's also the way, it's the teaching practices, it's the way that we're teaching, and I think that we are getting away from, here are definitions, we're getting away from this is the scientific method. If you don't hear scientific method, don't be alarmed. We're looking at science and engineering practices. So,
then are we and again, then just to follow up, are we going to giving them sufficient time and resources to do that? Because 100% of lesson plans rewritten that's a heavy lift.
it is, but you have to. The content is going to be the content. Science isn't changing that drastically.
Okay.
So the science is still the same, and they understand the practices. It's putting these all together.
Right,
it's
which
really
can be time consuming.
Absolutely.
I just want to make sure they have the resources to
Yep.
be successful.
Absolutely, and
fun.
right, and that's been my task at finding a great resource, which I do have a really good resource. It's Discovery Education. It's an online science tech book, and when I say online, it just has incredible resources, and they'll custom tailor it to the way our flow of what we're going to do. And you don't find that in many places. Being at this conference, I talked to many vendors, and it's very, package deal. This is what we have. And with this, there's a lot of creativity to go along with it. We're kind of getting away from textbooks and looking at more of this, understanding, doing hands-on stuff. And a lot of it's happening already at the middle school level and the high school level. So, and even at the elementary level, I've been in lots of classrooms since I've started. So,
It's not a concern because I've been reading a lot about these standards, is just sometimes our community is not always open, regardless of what the state says.
Mhm.
They're not always open so much to changing in programs, and so I'm going to come back to the staff. I want to make sure that we support our staff, give them all the resources to be successful with their students in the classroom and with the community that we're dealing with, so that everyone jumps on board and they can see. I personally do believe this is a better way to teach science. I think
We
it
just need to
aligns.
communicate that out.
Yeah, I
ahead
just
of
want
Right.
to make sure that we are proactive in communicating all information from all fronts.
Right.
We as a board need to do that
Right.
and make sure that, because I think sometimes our teachers end up being on the front line.
Right.
And it's really not fair to them. So
Right.
I think when we're thinking about all this change, which is happening, whether this is what is happening in the
Right.
state of New Jersey, and it's actually a positive change. So I think that would be my concern. So I think workshops are fabulous.
Mhm.
I think there needs to be a lot of conversation within our district and on teams and in all sorts of ways to make sure that we communicate effectively.
And I think, when we get going and we when the full implementation happens, I think parent information evenings are essential. I've done lots of them before just to make sure that we have, the parent support and they understand what it looks like.
Yeah. Just to let you know, just give you, it's about 15 minutes.
Okay.
Okay.
I'm almost done.
And I'll just reiterate, I mean, one of the reasons we wanted Kristen to be the first to kick off an open curriculum committee meeting this year was just that, to get the next gen conversation rolling with the public. And then follow up at, we oftentimes have PTO meetings and other places that are a little bit more intimate where Kristen can present. I also think that the secondary folks, our middle school teachers are really, we have a terrific set of science teachers at the middle school. As a secondary teacher myself, I never recycled my lesson plans. I always just did them new every year. But the content,
that's the norm.
but many times the content from year to year, or the units, if we had just written a curriculum, for example, in a certain course, and I was teaching those units again, I was familiar enough with the content that it wasn't so daunting to create the lesson plans. Not as daunting as it was in my first year of teaching when I didn't, I'd never taught a course before. So I think most of our science teachers all of our science teachers at the middle school are very collaborative. They've got great ideas, and I think we'll be in a good spot.
Right, I agree. And I think, we've already started. I've started them on this resource that we want to obtain and said, let's look at it. Let's see what we like about it. Let's see what we don't like about it. Let's see how you can use it in instruction already, this year. So all of those conversations are happening already. And, every chance I get to meet with them, we are talking next generation. We are talking plans for next year. We're talking about what it looks like.
Maybe on your website, we can have a timeline, where we're at and where you're going. This way, if a community member says, oh, you never told me that. Well, we've been talking about it since November, or you've been talking about it since, the 2011.
Right.
Or maybe if we see a timeline, this is where we've been, this is where we are, this is where we're going. So don't be shocked when the next milestone is hit.
Right.
Here's where we're heading.
Right. And I think it's helpful to see what it looks like in a classroom.
Sure.
Like those, those videos I think are really good just so that people can see this is what it looks like. We're doing science. We're not teaching science. We're doing science. There's a big difference between the two.
Correct me if I'm wrong, ladies, but sometimes people have difficulty with collaborative learning.
Yeah.
Yes.
So that has to be maybe packaged a little differently. I mean, it works beautifully, and I saw the kids using the correct vocabulary and back and forth. But when it comes down to the grading of this collaborative effort, it starts to get a little sticky.
Right.
It's certainly not an expert.
There's still individual assessments that happen. It's not that we're throwing that out. There's, that's still happening on that.
If there's a perception that one grade is dependent on another individual's effort, it gets a little sticky. I think I'm just throwing that out there as a cautionary.
I agree.
And we do collaborative learning. We don't do individual labs all the time.
Right.
At the high school level, we're doing them as an assessment. We do, but we're learning together along with each other.
I think though, Jill, and correct me if I'm wrong, I think what works in that respect with these standards is students have to demonstrate their understanding in many different ways, not just on assessment. They have to be able to share their thinking, they have to write about their thinking, they're given several different arenas in which they have to demonstrate proficiency. Not just on a test and then move on to the next quote-unquote chapter. So you see it in all the different sciences over the course of the year. So.
I'm on board. I'm just trying to highlight some potential.
I agree.
Right.
Yeah.
No, and I thank you for that. I agree. Thank you.
I think the parents might be uncomfortable with it, but I think the students,
I have
are.
no doubt.
Well, no, I think I would say for the current, say, the elementary population, they've been doing a lot of collaborative work, although they're not getting, like the A, Bs that they would get in the high school, but they're much more comfortable in
Never
that
concerned
scenario.
about the children getting it.
Yeah, no, that's important.
So this slide, I just wanted you to see how, so current sort of middle school standards, the way that they're written, distinguish between, describe, distinguish between, recognize. And so if we look at the next generation science standards, middle school sample, it's construct and use models. It's a lot more action that's happening in the next generation science standards. So we want, these are the active things that are going to be happening. So there's a big difference between the two.
So is there going to be an incremental cost to the district to put some of those?
I wouldn't say an incremental cost because, science equipment is science equipment. And I think, the cost might be for professional development. the one thing that I've been trying to do at the elementary level, at the K-5, is I have, invited myself into a lot of classrooms to model some things and to be that facilitator, just as that teacher did in the video, just to model how the question goes to get kids to think and do deeper. And we had a great time doing roller coasters and modeling roller coasters, but thinking about how the ball is falling down the ramp, what is making it happen, and getting students to where we want them to be, and then to be able to demonstrate it. So those things are happening. And we have implemented and started to purchase more things that are getting into the classrooms already, which is exciting. Okay, so this is our kindergarten through 5th grade plan. We've already have one unit at each grade level for K-5 that's being implemented now. So one of the tasks that I did when I came in was I looked at our current curriculum, and then I asked the teachers what they teach, because I wanted to compare the two, and I wanted to make sure that they were understanding what they were teaching. And I took the new Next Generation Science unit and I blended it into a topic that they're already teaching. So it's not an additional topic, it's let's look at these standards and blend it in. And so I've provided resources for them. I've set up shared Google folders for all of the teachers, and we are all just kind of sharing so many things and throwing a lot of resources in there. At the K3 level mostly, I've been using a resource called Picture Perfect Science. And what I love about this resource is it uses trade books to get students excited about the topics that we're teaching. And then it has all active hands-on things for the students to be able to do after reading the story to get them excited. And so in September, we already talked about the science and engineering practices and cross-cutting concepts and what that would look like in a classroom. I gave them all of their focus topics. They are aligning activities and resources. I've obtained some and brought them in. And so we have a little time with the K-5, but it's already starting. So by the end of this year, I'd like to have an additional unit written for each of those grade levels for them to start to implement next year. So by the time 2017 comes around, it's going to be, pretty smooth transition. So these are the resources that I have, just the Next Generation Science Standards website. The New Jersey put us through an EQUIP training. This EQUIP rubric actually looks at those lesson plans that you were concerned about to see if they are aligned, so they can look at their current lesson plans, see if they are aligned to Next Generation Science Standards, and then we can work together to make tweaks to make them aligned. And then the videos as well. There's also a link to the framework for K-12 science education if you're interested in looking at that. Just clarifies it a little more. And then a great parent resource page. So all these links are up on my website that you can take a look at.
I'll just note two other things quickly. Two items or two areas of change that have helped us, I think. From the student side, the implementation of the design and technology program, K-5, you can see it mirrors, it was built in part on the next gen standards, and the stuff that the kids are doing, the building, the constructing, the figuring out, the kids are accustomed to doing a lot of what's in next gen. And then the second thing is the change in the supervisory model has enabled us to schedule all of our supervisors with elementary level educators throughout the year. So at once every 6 weeks or so, maybe more often than that, depending on the grade level, Kristen is meeting with elementary level teachers, whereas before we never had that schedule in place. So our supervisors in the non-English language arts and math areas did not have a regular FaceTime with elementary teachers, and I think that's been very helpful to Kristen, probably.
It has been. So thank you.
Thank
Do I
you
have,
very much.
do I have time, Lana, for a
Oh,
question?
yeah, we have 5 minutes.
Okay,
Okay?
Have at it.
thank you very much. I'm going to go backward in chronological order.
Okay.
Or on my notes anyway. So the cross-cutting concepts, I was
Mm-hmm.
just curious, you had mentioned that Earth
you want me
and
to go back?
space science don't necessarily apply too heavily until they get to the higher grades. So,
I'll clarify that.
okay.
It's
I may have written it wrong.
That's okay. It's a change in the higher grades.
Okay.
So currently we have an astronomy class as an elective at the high school level. So one of the things that will be changing into that curriculum is we need to get some of the Earth and space into some of the other areas of science. So Some really lead itself to being in environmental, and some lead itself to being incorporated into physics.
Okay.
So we are going to kind of slide those in a little bit.
Okay, very
So,
good.
but we do have them all K through 12.
Is,
The Earth and Space Science standards are all K-12.
oh, or K to 12, okay.
Yep.
So then the cross-cutting concepts goes, at their level.
Right.
K-12.
Yep.
It's not delineated by any years that you introduce new portions of this quadrant.
No, it's all integrated
Cross,
throughout,
okay.
yep.
Very good. And then, can I ask another question?
Yes, you have time.
I have a question on the grading. So when you're doing these science and engineering practices, and, the video was excellent and it would demonstrate it, is it a different way of grading a student?
So that's a
Not
good,
just for that particular thing, but
Right.
across the new next-gen standards.
so, we use a lot of rubrics. One of the things that I had our teachers do at the middle school level when they're writing open-ended questions is we wrote a new rubric. We aligned them to the Common Core standards for science writing that are a part of reading language arts. And we looked at, the rubric that we wrote was students stating a claim, producing evidence, and reasoning for what they have. So the rubric looks a little bit different, and then teachers are tweaking their teaching of, open-ended questions to be able to align to that rubric so that students will get there. So the grading overall, I think it's like, as you mentioned, the collaborative piece, but it's also, exactly the way we would grade labs, because it's all the application. If we're doing a lab and I ask you to repeat the lab yourself, it's not going to be a grade for the 4 groups all together. It's going to be, can you apply it yourself versus can you apply it yourself? So the application is going to be individually based.
Okay, so it's not significantly changing the grade
No.
based on the
No.
next-gen standards?
No, but, in our report card, change, we are using a little bit more next generation science standard language.
Okay, so that'll help. Okay, and then
Yep.
my last question was a little bit, somewhat off topic, but since you're fairly new to the district?
Yes.
Is there anything that when you arrived here, you thought, oh my gosh, I can't believe Chatham does or doesn't have that? Is there anything that surprised you that maybe we're lacking in providing resources for? If you want to take it offline with Mike, that's fine, that's fair.
I think, I have to be honest, we were having this conversation today. I think Chatham was so forward-thinking with, starting a STEM program, especially at the elementary level. And I think that that's great that students have that opportunity to be able to do that hands-on piece. And then, talking with the principals to incorporate a little science, the D&T teacher does a little push-in at the elementary grade level, which I think is incredibly helpful. So I thought that is great that, the forward thinking of incorporating those engineering designs and that hands-on piece, which I think is great. And then, I think that the other piece, which is something that we've talked about, is technology.
Okay.
And I don't think that that's a secret. One of the, as I said, one of the resources we want to use is an online resource. Do we need to be one-to-one? Not necessarily to use it. There's so many different ways that you can use technology in the classroom to set up 4 computers, have it on a smart board, et cetera. But is it helpful for students to be able to be one-to-one in some aspects to be able to implement? Yeah, it is.
What about physical space, just physical, like a big empty room to build a model, to run a...
I think we have great space. Maybe we need a little updates maybe in some areas, but,
Okay.
But space-wise, I think that we do a great job. And you can always do science on a shoestring. If you need to grab stuff, there's always science in ShopRite. That's what I always say. You can,
Well, thank you.
great stuff. So,
Thank you.
We're going to answer.
Okay.
I don't need an answer to this right now. but
Sure.
Can you, what are going forward, what will be the curriculum, I know, let's say we do 90 minutes language arts, 60 minutes math a day.
The time.
What will the time, for K2, 3, 5, and I don't need that right now.
Okay.
So if you can get back to me, what will that new program look like, and what will,
Sure.
the hours per week, or
Right.
how it will break out?
Great. Yeah, I could definitely get that to you.
This is
All right.
fantastic, thank you.
Thank you. Thank you so much. Thank you.
And this is posted on your?
This is all on the, under the Science Department
Curriculum
website.
Science, got
Yep,
it.
yep.
Okay.
We'll have it on the district site too, after
Oh.
today.
Okay, fantastic, thank you.